Algebra 1, Lesson 55. We are solving systems of linear equations by graphing. When we look at our systems of equations, well, that means that we have two or more linear equations containing two or more variables. They are plotted on the same coordinate plane, meaning we are looking for an x and a y that satisfy both equations. So for example, we might see equations like 4x plus 5y equals 20 and 9x minus 14y equals 36. Now a solution to the system is that point that is on both lines. So it makes a true statement for both equations. So for example, let's try this one. We want to plug this coordinate in to see if it is a solution to the system. So we would say x is 2 and y is 3. So 2 equals 4 times 3 minus 10. Well, that would be 12 minus 10, so yes, we do get 2. And 3 times 2 plus 7 times 3, does that give me 27? Well, we get 6 plus 21, so yes, that does equal 27. So because both of them are true, this is a solution. This is the solution to the system of equations. Now let's look at this one. Same point, but two different equations. So let's try 3 times 2 plus 2 times 3 is equal to 12. So 6 plus 6, yes, does equal 12. How about 2 is equal to 7 minus 3 times 3? Well, we have 2 equaling negative 2. That's not true. So this is not the solution to the system of equations. So plug in your x and y in both equations to see if it works. Okay, so you could try this by plugging in 1 for x and get 4 plus 1. Does it equal 5? Yes. And how about 5 minus 3 times 1? So 5 minus 3, does that equal 4? No, it doesn't. So this is not a solution. Visually, we see the solution as an intersection of the two lines. So in order to find the solution, we need to graph our two equations. Well, we can see these ones are in slope-intercept form. So I'm going to use the y-intercept and the slope to plot these on my graph. So my y-intercept is 3 and my slope is 1 as the coefficient on x. So I have slope of 3, y-intercept of 3, slope of 1. So rise 1 over 1. Okay. And then for my second one, we're going to have a y-intercept of 1 and a slope of 2. So up 2 over 1, up 2 over 1, 2 over 1, all the way across. Or down to left 1. And we end up with a line like this. And they cross right here at 2, 5. Well, in order to check to make sure that's correct, because my lines could have been off, I can plug them in and see that y5 is equal to 2 plus 3. Yes, that's true. And 5 is equal to 2 times 2 plus 1. Yep, that's true as well. So 2, 5 is our solution. Let's do this one. And these are in standard form. So we can use my table of intercepts in order to solve this. So we have an xy table. We plug in 0 for x and 0 for y and do those individually to find out, okay, if x is 0, we have 3 times 0 plus y. So 0 plus y is equal to 9, so y is equal to 9. And we do it again with y is 0, so 3x plus 0 is equal to 9. Divide by 3 and x is 3. And we can plot these on our graph. My y-intercept is up here at 0, 9, x-intercept at 3, 0. So here is my line. And we do the same for my second equation. Let me just get rid of this extra line right here. And for this one, we have my xy table. And we plug in 0 for x, so we have 2y equals 8, so that means y is 4. 0 for y, we have x plus 0 is 8, so x is 8. So we have 4 for my y-intercept over 8 for my x-intercept. And it looks like they intersect right here at 2, 3. We can plug those in and see, okay, if x is 2, we have 6 plus 3, that does equal 9. And we have 2 plus 6 does equal 8. So that is our solution. Now, if we have a scenario, we might have to come up with some equations for this, and then plot them and find our solution. So, Mr. Nolan and Mrs. Drew want to rent bikes. There are 2 shops to choose from. One shop charges $10 per hour, and the other charges $4 per hour, but with a deposit of $15. At what number of hours will both shops charge the same amount? What is that amount? Well, first we're going to have to come up with some equations. And then we'll graph them and find the point of intersection. So the system of equations, we're going to have y, the total amount is equal to 10 times the number of hours. And the other shop is y is equal to 4 times the number of hours plus 15. So let's say each of my boxes on my y-axis is worth 2. And my x-axis will stay the same. Okay, so I can plot my my first equation by saying we have 0, 0, 1, 10, 2, 20, and so on. We have my first equation. And then my second one, we're going to have to go up 15 to start. So we're right here. And then for every hour I add $4. So we go from 15 to 19. And from for 2 hours, we are at 23. So up here, up more. So we see that we are going to intersect up here. Well, when we do it, it's actually going to be between 2 and 3 hours. It's actually 2.5 hours for x. Which means if we have 2.5 hours for x, well, then we see if we plug that into one of our equations, we get $25 for y. And that is the same for both equations. Okay. Now, some of these will ask you to use a graphing calculator to try these out. But a graphing calculator needs it in slope-intercept form. So first I'm going to change each of these to slope-intercept form. So we get y is equal to negative 2x minus 2. And we have y equals negative 3x minus 5. So we're going to use a graphing calculator to do each of these. So let me just bring that up. Let's see if I can get this in view. Let me just play around with this for a second. There we go. All right, so when we do this, we're going to go to my y equals button and put in both of these equations using the negative sign here to put in my negative 2x minus 2. And then for my second equation, I'm going to have negative 3x minus 5. And I'm going to go ahead and go zoom number 6, z standard, and I'm going to see both of these. And it looks like I'm going to have a intersection right around here, but let's find that. First, using our trace button and going as close as we can to it. Looks like it intersects about there, so maybe like negative 3, 4, something like that. But our calculator can help us find the exact intersection by going second trace, so getting to the calc position, and number 5 intersect. And it says first curve. Well, I'm going to say my first line is this one. Press enter. Second curve, my second line, yes, I'll be on that one, and then I'll guess. I'll get as close to the intersection as possible to help the calculator and press enter. And my intersection is at negative 3, 4. That is the point that satisfies both of those equations. Okay, so you can use your graphing calculator to do this as well. Okay, so you can, here are some other examples that you can try. Just remember, you're looking for that intersection. All right, well, I hope this is helpful for your homework and for studying.